I want to look today at complex and imaginary numbers and just give you that quick overview that we've already learned. In complex and imaginary numbers, we have a definition of I, something you just have to remember from now through college algebra. I is equal to the square root of -1. You need to know that and remember it. I squared is equal to -1. Where they get that is, by definition, if I is equal to the square root of -1, and we want to get rid of that square root. To undo a square root, you square. Well, then we have that I squared is equal to, these cancel, -1. So I have my definition. I know that I squared is equal to -1. There's two more exponents that I really want you to know, and that is I cubed and I to the fourth. Now, if I go back and I just put in here that I to the 1 is equal to I. Okay, that's just kind of a given. Any exponent raised or any variable raised to the first power is just that variable. And I come down and go, let's kind of define I cubed. Well, I cubed is the same as I to the 1 times I to the 2, because 1 plus 2 is 3. I know that this is I. I know that I squared is -1, so this answer would just simply be -I. If I were looking at I to the fourth, that's the same as I squared times I squared, because 2 plus 2 is 4. I know that I squared is -1. So this is -1 times -1, which is +1. And you'll find if you go through, as we did in class, that as I keep going to I to the 5th, I to the 6th, I to the 7th and 8th, that this pattern will just continue. In other words, I to the first is equal to I to the second is equal to -1. I to the third is equal to I to the fourth is equal to 1. And as you continue this pattern, as we did here, just pulling those variables out, I'll find that I to the 5th is equal to I to the 6th is equal to -1, I to the 7th is equal to -I, and I to the 8th is equal to 1. You're going to follow this pattern. I, -1, -I, and 1. I, -1, -I, 1. And it just continues over and over again. So as we use this, we're going to kind of plug into some of those numbers, or those exponents, and we're going to find the value of that I, whatever it is. So let me explain what I'm talking about. If I have I to the 10th power, since I to the 4th is equal to 1, and I'm just going to continue to use this, that I to the 1 is equal to I squared is -1, I cubed is -I, and I to the 4th is 1. So I'm going to kind of plug into that 10, and I'm going to use 4 because it's equal to 1. And I say 4 will go into 10 2 times, which is 8, with 2 left over. Well, I squared is -1. If I look at I to the 21st, 4 will go into 21 5 times with 1 left over, and that's just simply I. If I look at I to the 43rd, 4 will go into 43, 4 will go into 43 10 times, which is 40, with 3 left over. Well, if I look over there, I cubed is -I. And if I have I will go into I to the 16th, 4 will go into 16 evenly, so that answer is just going to be 1. Your final answer will only be plus or minus I, or plus or minus 1. You won't have any left over exponents, so you won't have an exponent for I. If you do, then you need to break it down. So here's some more, just to practice. If I have I to the 33rd, 4 will go into 33 8 times, which is 32, with 1 left over. So that's I to the 1. If I have I to the 18th, 4 will go into 18 4 times, which is 16, with 2 left over. That's I squared. Well, I squared equals to -1. If I have I to the, let's say, 45th, 4 will go into 45 11 times with 1 left over, so that's just I. If I have I to the 15th, 4 will go into 15 3 times, which is 12, with I to the third, 3 left over, and I know that I cubed is negative I. Anything that's a perfect multiple of 4, such as I to the 20th, it will go evenly, then that answer will be 1. And some of those you just have to practice and play with. So let's just kind of get into it and find out how these complex numbers are going to be. Complex numbers are complex because they mix real and imaginary. So if I'm looking at this, the standard form is a plus bi, where this is your real part, a, and this is your imaginary part, which makes sense because it has an I with it. So over here, first of all, I just want to take the square roots when we have the positive and when we have the negative. So if I have the square root of 50, I'm going to break that down into what I do know and what I don't know the square root of. I do know the square root of 25, 25 times 2. So this is 5 square roots of 2. If I have the square root of negative 36, I know the square root, first of all, I know the square root of negative 1, and I know the square root of 36. The square root of negative 1 is I. The square root of 36 is 6. So this answer is 6I. The square root of negative 1 is I. That's where I get it right there. In 28, the square root of negative 28. I know the square root of negative 1. I know the square root of 4. However, I don't know it of 7. These I know the square root of. The square root of 4 is 2. The square root of negative 1 is I. But I don't know the square root of 7. So I write this as 2I times the square root of 7. You don't want to put the I at the end because it gets confusing as to, if the I is underneath the radical or not. So it's treated like a variable and written out front. The square root of 48. The factor of 48 that I like to use is 16. 16 times 3. The square root of 16 is 4, leaving the square root of 3. And then I have the square root of negative 63. I know the square root of negative 1. I know the square root of 9, but I don't know the square root of 7. I know the square root of 9. I know the square root of negative 1. The square root of 9 is 3. The square root of negative 1 is I. So this is 3I square roots of 7. Now the square root of negative 1 is I, not the square root, not the cube root of the fourth root. It's got to be the square root. So if you go back and look, it's those numbers that have a negative underneath the square root sign that have the I in the answer. So kind of watch out for that and be careful. In these problems over to the left, over to the right, over here, I first want to take the square root. The square root of 121 is 11 minus the square root of negative 16 is 4I. Now not negative 4, but 4I. So I look at this, is this written in A plus BI form? Yes. Where the real number is 11 and the imaginary number is negative 4. Where A is 11 and B is negative 4. In 7, number 7, I have negative, and then I have the square root of 20. If I were to break down the square root of negative 20, the square root of negative 20, I break that down into negative 1. I know that square root. I know the square root of 4. However, I don't of 5. So this is 2I square roots of 5. So right here, this is the negative just follows 2I square roots of 5 minus. And then the square root of 49 is simply 7. Now, here, this is not written in the proper form of A plus BI. So I need to just turn it around. Negative 7 goes first, minus 2I square roots of 5 goes next. On number 8, I'm going to take that square root. That square root of 196 is 14, plus the square root of negative 1, which I've learned today, is I. This is in the form of A plus BI. What I want to show you here is that A is 14 and B is the number in front of I. In this case, that understood number would be 1. But 14 plus I would be my answer. We'll continue on with other aspects of complex and imaginary numbers on the next slide.